Behind the scenes, conversations with European researchers and innovators.
Keep an open mind and an open spirit, and then try again if things don't work.
In this podcast, we will hear the inspiring stories and journeys of Europe's most brilliant scientists and innovators whose discoveries are having an impact on our daily lives. Here's how they got to where they are. These are our top stories. Our first guest is Aleksandra Walczak, physicist and currently a CNRS research director at the École Normale Supérieure in Paris, France. She is working on the biophysics project Struggle Basic Science, an EU-funded project that can be useful to understand why we are reacting differently to COVID. Aleksandra, thank you very much for being with us here today from Paris. First, before we talk about your specific projects, could you tell me more about your area of expertise, physics? What does physics mean to you? Where does your love of it come from?
So for me, physics is a certain way of looking at the world, a certain tool set, a certain approach, a certain way of asking questions about real-world phenomena that can be very different, but that is able to provide concrete answers that can then be both experimentally tested, but at the same time give us insight into how the world functions. And what I love about it and what drew me to it is that it opens more doors than it closes in every sense of the word.
So you're a physicist, but more precisely a biophysicist. So tell me what that means exactly and what led you to become a researcher.
So I've always been fascinated by the living world, by biology, but I was a bit scared of all the facts that you have to memorize when in school, when you're taught biology. It just seems very fact heavy. So that's why I wasn't that drawn to studying it. On the other hand, physics seemed to flow more easily. And then I discovered statistical physics, and these two things came together for me. So statistical physics is the part of physics where we realize we don't have to track every molecule at a time, but we can take a step back and describe general laws and general behavior of these large-scale systems. I thought that this is really an extremely powerful approach that completely blew my mind. And it also turns out it's very useful for describing phenomena in living systems. So I think that's what brought me to the field initially.
Okay, well then let's talk about your specific project that you're working on now, and feel free to touch on projects that you've already completed. Tell us, the outline of what it is before we get into the detail.
So what I work on is understanding how the adaptive immune system functions. So we all have an immune system, which is made out of B and T cells that protect us against the many pathogens we can encounter, including pathogens that may not be around at this time or were not around when we were born. And it's not a system that has a leader, is somehow organized as a central system. So it's what we call the self-organized system. And what I'm interested in is how these cells work together and interact, and what diversity has to be in order to protect us against different pathogens. So, for example, when you go in and you get a blood test, you have a line that talks about white blood cells or lymphocytes, and you measure their counts. And because if the counts are high, that means you have an infection. But what I'm interested in is going a bit deeper into that and understanding which types of cells precisely go up when you have an infection and what's so special about them, and can we understand that?
So fundamentally, you're working out how the immune system works.
Yes, that's exactly it.
So to be clear, that when you're working out how the way our immune system works, that is quite theoretical, isn't it? Is this basic science?
Yeah, so what I do is basic science, and it's a basic science project funded, in fact, by the physics and engineering part of the ERC. And what I'm interested in is really the rules. What are the rules, the statistical rules that make this system work and make it function? Because, I mean, most of the time our immune system does protect us and does a pretty good job of that. But of course, as I said, I'm a physicist, so I'm interested in the real world, meaning that what I study is around us. In our case, it's in us. It's not that basic science is something that's completely devoid of any links with reality, but it just studies basic questions to understand how things work.
That's basic science, but clearly there's now also a societal issue connected to it with COVID. Can you remember the first time you heard about COVID-19, and at what point did you realize the huge impact it would have on your work?
I mean, I heard about COVID-19 at the same point that everybody did, and then it took over our lives very quickly. So, it's not the first pandemic that happened in recent years. We had MERS, we had SARS, so I didn't think it would be this big, and I didn't think it would get so close to my research, although I did automatically realize that the questions that I'm interested in right now about coevolution between viruses and the immune system is clearly relevant. But I started working on COVID as data became available. So I'd say March.
So 1 year later, tell us how you've integrated this new data into your project. I mean, and also perhaps how it has disrupted your project expectations.
I mean, for the disruptions part, I think this will be common to everybody you talk to if you ask them the question. I mean, it had disrupted my life and the life of my collaborators, just as it disrupted all of our lives, that, well, working became harder. It's sort of reality caught up with basic science, which I think gives a beautiful example of why, again, understanding the laws of nature, it is maybe an abstract thing to do, but it has direct implications on our everyday life. So my project really is about understanding how the immune systems of different people drive viral evolution and how viral evolution impacts the immune systems of different people.
You've been working on this project and previous projects for many years now. So can you tell me about your results, a little bit more about the outcomes of maybe past projects and this particular project and your expectations in this COVID context?
Yeah, so I mentioned one of the results already, that we were able to computationally identify cells, T cells that responded and recognized COVID proteins. And we were able to see how different are these cells in different people. The thing to realize about the immune system, again, it's the statistical huge system with billions of cells. It's not that there's just one golden bullet that gives you protection. So what is the diversity of these cells that give you protection, and how does it change with time, and how stable it is? So these are the kinds of questions that we answered in COVID, and we were able to trace back this pre-existing immunity. And we were able to show that people that have similar molecular machinery for interacting with COVID peptides or any other peptides have quite similar responses to COVID, no matter where they live, what they do. So it sends the message that there is some hope, that there's maybe a method to this madness, and there's some hope in making predictions and understanding how it works.
We've talked a lot about how your research applies to COVID and how you started working on available data as of March, but we'd also like to understand, how was the reaction of the European research community at that moment?
So I think everybody who was anywhere close to COVID started thinking about it. And there was a lot of momentum and a lot of good ideas. And even people who were doing other things were asking themselves, how can I change? Do I know anything? Can I be useful? I think that was very inspiring and helpful. And I think it also brought a lot of people closer. It made people realize that sort of real world problems are maybe closer than they think.
How did researchers come together to share and analyse data? Did the EU help on this? And if so, how?
So the EU in general has a great open source and data sharing policy. I mean, I think in general it's great and everybody should adopt, but I think people like me especially benefit from it because I don't have my own wet lab. I don't produce my own data. I either work with people who produce data, but even when I work with people who produce data, I very often use data from public databases. And so, for example, on the project that I talked about before, where we identified T cells that respond to COVID, we could not have validated our results without public databases. I think with sort of careful work, public databases can really allow for finding great answers. And I think this is extremely important.
According to you, what are the main assets of the European research? How is the EU helpful in your area of expertise? How did you find out about EU funding?
Oh, it's definitely important because especially if we think about something like COVID, but this is just an example. I think it's generally true for everything that I do. But I think COVID is an example that will speak to everybody. If we solve the problem locally in our own countries, that won't solve the problem at all. And I think anybody who believed that has now been proven wrong so many times that we really need to have not just a European approach to the problem, but a completely international approach to the problem. And we need to sort of work together and we need to share data and share know-how and sort of trust each other a little bit more and learn from each other's mistakes and experiences. So I think the global aspect is incredibly important in this. So I think the greatest thing in my own experience about the EU funding is that they took a chance on somebody like me who comes from biophysics, who comes from physics, and wanted to work on the immune system. So I think that experience of really just giving me the opportunity to take an idea and run with it and giving me the time to develop a project and the space to think about it at a place that was really at the intersection between different fields. I think this was a tremendous opportunity. The EU has also a lot of international training networks and international collaborative projects from which I'm also benefiting. And I think this is great because it allows, again, students from one country, PhD students, to go and work in another country and see how research is done. But it also puts people in touch with each other. But even your own projects, they sort of give you enough freedom to go and look for collaborations where you need to find them.
And how was it for you to come from one EU country to work in another?
I think it's generally great to be able to work in any European country you work, and working in a different country, whether it's the one you come from or the one you find yourself right now, offers you a unique perspective. It makes you a bit of an outsider if you've had experience elsewhere. So you can actually appreciate things that maybe the locals don't appreciate themselves because they take for granted. But on the other hand, it gives you ideas that they maybe wouldn't have. And on top of that, what's great about Europe is that a different country with a different system is very close by. So you can often go to another place and get inspiration, see how things are done differently, and see whether there's a way of sort of bringing the good stuff back to where you work.
A final question then. What advice would you give to your younger self? Whether that's research, career, science, the world, anything.
To be open to opportunities and don't think that that's not what I do, so that's not what I'm going to be doing, or that's not where I want to go, so I won't even look there. So just keep an open mind and an open spirit, and then try and try and try again if things don't work.
Thank you. That seems a very positive outlook on the world. Our next guest in this series will be Phil Ayres, and he's an architect who works on future buildings with a very original solution, fungi. Aleksandra, is there anything you would like to ask him? We do want our scientists to ask questions of each other because obviously you know more about it than even us journalists.
Yeah, I mean, I do have one very silly question, which is, won't it smell bad? And the maybe more scientific question is, how do they plan to control different types of fungi and different kind of also bacterial communities growing together? Because, these things are living, they have a life of their own, they can form communities that you didn't expect. So I'm sort of curious how this is going to be controlled.
Thank you very much, Aleksandra. I will be sure to put both those questions to him, so please keep listening to hear the answers on our podcast. And of course, more information about your projects can be found online. Check the details of the episode for all the links and more information. That's it for today, but do join us again next time for more behind-the-scenes conversations with Europe's most brilliant scientists and innovators, giving you an insight into how the EU's investments in research and innovation impact our daily lives.
This podcast series is brought to you by the European Commission, and you can find it on all listening platforms. If you enjoyed this conversation, rate this podcast on all listening platforms and share it with your friends on social media.